Welcome to a new video in my 7.25-inch gauge build series, and this weekend I had made a very good progress because I managed to assemble the two bogies. Besides that, I got two layers of gray paint on the roof of the loco as well. That was also good, but that was the main the milestone for me, is to get the bogies assembled. There was nothing really complicated about it because it was just assembly. Everything was painted, everything was ready, but it's done, and they seem to be running quite well, and of course I had to test it. So what I've created, I created this basically pull rod that I could connect. Well, it connects to the kingpin, and then it connects to one of my driving trolleys, or that was my earlier driving trolley, and I just picked up one battery and a very basic PWM controller, and I made a very simple hand controller so I can test how it runs. I was more wanted to see how it performs mechanically, not so much as in pulling power, because obviously I was driving it using half the voltage. It's just one battery, so it's 12 volts, and there is no weight on the bogie. So by the way, I weighed this bogie, so it's 32 kilos, so that's around 70 pounds. So obviously it had limited traction because you can see in some of the footage that it actually slips when I applied full power. But it pulls me. It sort of behaves like my loco, to be honest. So it goes up the hill, but I really have to give it some momentum. But given the fact that it's only running half of the power, it's only one bogie, and with proper weight on it, it would have more traction. I think definitely looking at a very powerful, fairly powerful loco, as sort of I was expecting. And I think the speed is also good. Maybe it's a little bit, it could be a little bit too much, because even full throttle on this one, which is, as I said, just half the battery, so I'm assuming it just, half the speed, it was still plenty fast. But again, in my small garden where the space is confined and the tights are curved, everything, seems a little bit faster than it actually is. And by the way, you can see some footage now, and I managed to get the GoPro to look at the chains, how the chain is behaving. Probably you have seen this footage already. I mean, I can't really sync the pieces of the videos to what I wanted to say now. But it looks like that when the bogie is running, the chain is not really flapping around too much in the breeze, because I was concerned that maybe the chain is too loose and I need chain tensioner. But just by looking at the videos, it looks that it's under tension and under load, it seems to be fairly normal. Of course, when I'm braking, stopping, changing direction, then it starts to wobble a little bit around, but there is nothing that would indicate that I would have an issue with the chain tensioning. So hopefully that's going to be enough, and I can just go on. We'll see. And I think I also have a footage when I tested how it behaves on the curves, because again, I was thinking that maybe I have, I know that this is a much shorter wheelbase than my actual driving trolley, and when I moved it around in a curve, I could confirm that there is quite a lot of play, because I think my gauge is an extra 5 millimeters in the really tight curves, and this bogie is definitely not tight on the curves, so that's also good. So again, I was going up and down. I also had a voltmeter, so in some of the footage I was looking down, and the top current draw was actually like 25, 30-ish amps. So that's not insignificant, but again, this is a very challenging track. So I think in the club or in the museum, where it's mostly, it's definitely flat and it's very light curves, I think the current draw is probably going to be much less, maybe around like 5 or 10 amps. But we'll see. So let's get on with the build part of the video, or the build montage. And so first, what I've done is I just had to prop up the bogie frame, because the kingpin is now welded in, and I was first putting in the springs. Again, I was buying a lot of different springs. Actually, some of the springs that I bought arrived after I've done the assembly, so I've used the spring that I have at the moment, and I'm not sure, maybe it's a little bit too much, but I will have to see, you know, with the full loco how it behaves, you know, whether it's going to be too stiff. I need to go for a lighter spring, but that's something that I would design. And so first I was putting all the springs in, and I got the bearing blocks, and I don't know whether it's really necessary, but I put some grease on the end of both springs. I mean, after all, they will be moving around, scratching the paint, so maybe this grease is going to help with, you know, minimizing the rust. I'm not sure, but anyway, I did that. And I also lightly greased the parts where the bearing block is going to slide inside the bogie frame. Well, it's definitely going to hit that from time to time, but there is quite a lot of play in it. Again, I'm not sure if that was required, but I had this grease lying around. And originally, I thought that these bearing blocks, they come greased from the factory, but somebody said that some of them get some grease, some don't. So what I did next is I made sure that I fill up with the grease. So I had these grease nipples, and I bought the grease can, and I also bought this grease cartridge or this tube. Then only to find out that the grease can that I bought it doesn't work with this tube. So I had the fun of basically scooping out the grease from the tube and putting it into the gun. Yeah, it's another 15-minute or half an hour job that I shouldn't have done if I've paid enough attention. But this is the first time I'm using a grease gun, and it doesn't perfectly fit on the nipple. I don't know whether it should or not, but it ended up being a two-man job. Like, I had to push it on the grease nipple really hard, otherwise it would just ooze out at the nipple. But anyway, I think I got everything greased up. I cleaned up the rest, and once that was done, all I had to do is put on these end blocks, which will stop the bearing blocks to come loose. And yeah, and that was the one big I mean, these were you know, the two biggest ones. I even forgot to mention that I was putting the motor in first, but you know, they had the motor mounts, so that was fairly straightforward. And then finally, I was doing the one which I dread the most, is putting the chains on, because last time I tested with the chains, it was really, for some reason, it was really difficult to put that clip, that double C clip, which is going to hold the that extra piece in place. But for some reason, when I did it this time, it was, you know, it was fairly easy. Yeah, I put it in place and I used the screwdriver, and I was able to just snap it on, and there were no issues at all. So anyway, the chain was on, and I moved the whole thing over closer to my power supply because I wanted to check the alignment. So I was running the motor on a low speed, making sure that the chain runs perfectly and both of the chains are aligned. And when I thought that the alignment is correct, then I tightened the set screws on the bearing blocks, and that should keep the wheels in that position. I think what I would do is probably I would do some more testing with this bogie, and then once everything is fine, I will go back to these set screws, and I would just add a little bit of Loctite just to make sure that they stay in place and they don't get well, they don't unscrew from the vibration. So I think that would be pretty much all. As I said, I think I mentioned most of the design challenges and then some of the design thinking in the past. So that was a straightforward assembly. I obviously filmed one of the bogies, but the other one got assembled as well. Actually, you see the testing of the first bogie, but then the assembly video is of the second one, where I had a little bit more practice. So I had all the screws and nuts and everything in place. So it went much faster than the first one. And yeah, I had no issues. I've already prepared the chains in the past, so I already had the correct length. And yeah, it was much easier than I thought. You probably noticed that the disc on one of the axles, and yes, I'm planning to put a disc brake on, but I haven't got any of the brakes. I haven't figured out how I'm going to design that, and probably for the first time when I'm using this loco, it's going to operate without brakes. So I would probably just use the the controller for braking and you know, just drive it carefully. But who knows, maybe I'm going to have enough time and I go to my brother recommended me like a local shop here, like a bicycle shop, so I think I would just go for a mechanical disc brake that are sold for bikes, and that should be enough. Just like not so much like, you know, the final brake just to stop the loco, and also what is it, parking brake. I think that's going to be the main thing, and otherwise I would just use the engine brake or the electronic brake for the, you know, the general slowing of the vehicle. I don't think it's going to be worse than on my previous loco, and with a 4QD controller it was, you know, fairly sufficient. So I'm expecting sort of the same performance on this one as well, and probably the gearing in the motor will help me as well, just to reduce the speed. But we'll see once the full loco is assembled and I can test the whole thing with the whole weight and everything. So hopefully that's going to be in the next video or in one of the next videos. Next task is me to get the electrics done. So I had the main chassis had all the layers of paint, so I can just start mounting the controller and some of the other bits and pieces. And once that is done, it's basically final assembly. Of course, I have a few more layers of paint that I need to do, but at least I can do these other tasks in parallel. So I think that will be all for today. Thanks for watching, and hopefully see you in the next video.